Hello everyone, welcome to Victory Batch. This is me, Arvind Suthar. I welcome you all in this session on complex numbers. It is going to be a one-shot lecture. So let's go into the session and let's nail this topic. Complex numbers. The name itself contains complex, but the chapter is not at all. Let me tell you, it is a very easy topic if you are having good command over the basics. So I'll try my level best to make it easier for you guys. In real numbers, we have noticed one thing, that square root of a negative number is not defined because that number always comes out to be an imaginary number. If I talk about under root minus 4, this is not a real number. This is an imaginary number. Rather, it is written as 2 iota. If I talk about under root of minus 9, this is 3 iota. Yes or no? Which are not real numbers. So there is no real number satisfying this particular equation as well. Yes or no, everyone? Yep. So x square, when mathematicians got to know this equation x square plus 1 equal to 0, they had an idea that there is no real number x for which this equation is satisfied, because if x square plus 1 equal to 0 is rewritten, it can be written like this. Then x equal to plus minus under root of minus 1 is coming, but under root of minus 1 does not exist in the real numbers, and hence one new set of numbers came into the picture, and that is complex numbers. So under root of minus iota was designated as, under root of minus 1 was designated as I, that is iota, and accordingly under root of minus times of under root minus 1 will now become minus iota. Yes or no, everyone? So the solution of the equation were called as plus minus iota, and these are imaginary numbers. So let's get to the definition of complex numbers. Any number which is written in the form of a plus ib, where I is under root of minus 1 and a and b are real numbers, is known as a complex number. So complex number can be categorized into three ways. Number one, they can be real numbers as well, because if the imaginary part of the complex number, that is b, is 0 in a complex number, then we say that those numbers are real numbers. So the numbers like 1, 2, 1 by 2, minus 1, these are all having imaginary part, that is b equals to 0. So in that way, we can say that all real numbers are also complex numbers. Okay, talking about purely imaginary numbers, if the real part of this complex number a is equals to 0, then the complex number becomes I into b, where b is the real number, though b is known as imaginary part of the complex number z, right? So all the numbers like I, 2i, 3i and minus I and so on, these are nothing but purely imaginary numbers. Then talking about the third one, whom we call as imaginary numbers, where a and b are both not equal to 0. So the numbers like 1 plus I is a imaginary number or complex number. 4 plus 2i can also be called as imaginary number, because here neither a nor b is equals to 0. Over here, if you see what is the value of a is equals to 1 and b is also equals to 1. So the real part of the complex number 1 plus iota is also 1, and the imaginary part is also equals to 1. If you look over here, the real part of the complex number 4 plus 2i is 4, and the imaginary part of the complex number 4 plus 2i is 2, not 2i, it is 2. 2 minus 3 iota, if we see, the real part is 2 and the imaginary part is minus 3. And if we see this number 5 minus I, the real part of this complex number is 5 and the imaginary part of this complex number is minus 5. Yes, minus 1, sorry. Yep. Okay, points to remember. All real numbers are also complex numbers with imaginary part equal to 0. A set of real numbers is a subset of complex numbers, because I hope you might have studied this, that natural numbers is a subset of whole numbers. Whole numbers is a subset of integers. Integers are a subset of rational numbers, and rational numbers are a subset of real numbers, and real numbers again are a subset of complex numbers. Yes or no? Okay. 0 is the only number which is both real as well as purely imaginary, because 0 can be written as 0 plus 0i. Over here, a is 0 means it can be called as a purely imaginary number, and b is also 0 means it can be called as purely real number. Yep. Okay. If a and b are some real numbers given to me, where a is not equal to 0, and the quadratic equation this ax square minus bx plus c, over here you can see that coefficients are all real. I said okay. And a is not equal to 0, and this is having imaginary roots. Okay, if this is having imaginary roots, then don't you think that the roots has to be Complex conjugate roots, complex conjugate roots. Yes, because in quadratic equations, you might have studied this, that if coefficients are all real and discriminant is negative, then the roots are complex, number one. And those roots, complex roots, are conjugate as well. Yes or no? So over here, if it is saying that imaginary roots and the coefficients are all real, means the roots has to be complex imaginary roots. I said okay. So accordingly, we can say that the value of this is going to be negative only. Okay. Then now it is asking us about a plus b plus 1. If you remember, I have told you that if f of x is like this, then what should I put in place of x so that I get a plus b plus 1 from here? What should I put in place of x so that I can get f so that I can get this kind of an expression in quadratic equations we have learned? So it is nothing but f of minus 1, right? So the question wants to know the sign of f of minus 1. The question wants to know the sign of f of minus 1, right? Okay. Now, imaginary roots can come in two cases. Either the graph is like this or the graph is like this. Yes or no? So if this is the case, the quadratic expression is always positive. If this is the case, the quadratic expression is always negative. So nothing can be said about this. Yes or no? Nothing can be said about this. So a plus b plus 1 ka value is going to be what? Nobody can tell you. Nobody can tell you, bacha party. So it is dependent on the sign of b is what you can say as of now. Or one thing is this, and also if discriminant is negative, let's evaluate over here, that if discriminant is negative, then b square minus 4a has to be negative. That means b square has to be lesser than 4a. Okay, if b square is less than 4a, now understand one very important thing. B square is a positive number. It should be less than 4a, means 4a has to be a positive number. If 4a is a positive number, then that means a has to be positive. So in this particular question, a has to be greater than 0, means this graph is not possible. And if this graph is possible, f of minus 1 has to be positive or negative. It has to be positive only. So that's why the answer is going to be option A. Look, a quadratic can either open upwards or open downwards depending upon whether a is positive or negative. Number one. Number two, that the discriminant is negative means these two cases are there. Now, discriminant is negative also means that b square minus 4a has to be negative, means b square has to be less than 4a. Now, b square is going to be a positive number because it is a square. So 4a also has to be positive only. Because if 4a is negative, then b square can never be less than 4a. So 4a has to be positive only. If 4a is positive, means a has to be positive. A positive means only this graph is possible and this graph is not possible. If a is greater than 0, that means for any real value of x, the quadratic expression is going to be positive. So f of minus 1 also needs to be positive, means the correct answer of the problem is going to be option A, right? Yes, a very good problem as far as conceptual clarity is concerned. So I think the problem is clear to all of you guys. Okay, moving on to the next concept. Under root of minus 1 is nothing but iota. If you do iota square, then it is minus 1. Iota cube, it is minus iota. And iota to the power 4 is nothing but equal to 1. Okay, now iota to the power 5 can be written as iota to the power 4 into iota, that is 1 into iota, that is again equal to iota. Yes or no? Because iota to the power 4 is how much? 1. This is minus 1, minus iota and 1. Now, you must know that over here cycles are formed. I will come on to that, but before that, let me tell you that over here you guys can see that this is an imaginary number, this is a real number, this is imaginary number, this is a real number. So iota to the power 2, iota to the power 4, iota to the power 6, iota to the power 8 and so on. These terms are going to be real numbers. Yes or no? Iota to the power 2, iota to the power 4, iota to the power 6, iota to the power 8 and so on. So these numbers are real numbers. Whereas if you talk about iota to the power 1, iota to the power 3, iota to the power 5, iota to the power 7, iota to the power 9, these are all imaginary numbers. Yes or no, beta? Yes, sir. Number 1. Number 2, there is a cycle which is formed, which does get formed over here. That is iota to the power 1 will be equal to iota to the power 5 will be equal to iota to the power 9. iota to the power 9 equal to iota to the power 13 equal to iota to the power 17 and so on, because these numbers are of the form I to the power 4k plus 1, where k belongs to an integer. Yes, okay. If we talk about iota to the power 2, it will be equal to iota to the power 6, it will be equal to iota to the power 8, it will be equal to iota to the power, okay, sorry, 10, then 14 and so on. And these numbers are of the form iota to the power 4k plus 2. Okay, yep, okay. Talking about the third thing, iota to the power 3 will be equal to iota to the power 7 equal to iota to the power 11 equal to iota to the power 15 and so on. These numbers are of the form iota to the power 4k plus 3, so that's why these are all equal. And if we talk about iota 1 or iota to the power 4, iota to the power 8, iota to the power 12 and so on, these numbers are of the form iota to the power 4k. Yes, so these are all equal. So if I talk about what is the value of iota to the power 217, can anybody tell me iota to the power 217? It will be equal to iota to the power 1 only. Why? Because 216 is a number which is divisible by 4. So the category is going to be this one. So if this category is there, then it is equal to iota to the power 1 only. That is equals to under root of minus 1. Yep. Okay. One thing. Another thing is the summation of 4 consecutive powers of iota is equals to 0. Over here, this is iota to the power 0 plus iota to the power 1 plus iota to the power 2 plus iota to the power 3 is there. That's why this is equals to 0, because these are 4 consecutive powers of iota summation written over here. If I talk about iota to the power 5, iota to the power 6, iota to the power 7, iota to the power 8, that summation is again going to be equal to 0 only, because iota to the power 5 plus iota to the power 6 plus iota to the power 7 plus iota to the power 8, these are again 4 consecutive powers of iota. So again that is going to be equal to 0 only, right? Okay. The reciprocal of iota, if I talk about reciprocal of iota, I need to calculate the value of 1 by iota. Now what I'll do is I'll multiply and divide by iota. In the numerator it is going to be 1 into iota, that is iota, and the denominator is going to be iota square, and iota square is nothing but minus 1, so this thing can be written as iota over minus 1, or again it can be written as minus iota. So I hope you guys are clear with this. So these are very important results written over here. Sum of any 4 consecutive powers of iota is equals to 0, and product of any 4 consecutive integral powers of iota is nothing but equal to minus 1, because over here you can check the product of any 4 consecutive powers of iota is always going to be equal to minus 1 only. You can take 3, 4, 5, 6, iota to the power 3 into iota to the power 4 into iota to the power 5 into iota to the power 6. If you do that as well, it is going to be equal to minus 1 only. Do remember these important things. So iota to the power 4n, where n is an integer, the value is going to be 1. This is going to be iota, this is going to be iota square, that is equals to minus 1, and this is going to be iota cube, that is equals to minus iota. Do remember these things, kids, right? Okay. Remember that iota raised to the power any integer can always be reduced to 1 or iota to the power 1 or iota to the power 2 or iota to the power 3, as I told you. For this, divide power by 4, whatever is the remainder will remain there. That means what? If I ask you to do this iota to the power 2004, so you divide 2004 by 4, what is the remainder coming? The remainder is 0. So you can write down this expression as iota to the power remainder always, and over here it is nothing but iota to the power 0, so the answer is going to be nothing but 1. Okay, talking about this iota to the power 2015, so what you're going to do is you're going to divide this 2014 by this. The remainder is going to be how much? The remainder is going to be 3. So the same expression can be written as iota to the power remainder, so that is iota to the power 3, and iota to the power 3 is how much? Minus iota. So the problem is solved. Yep. Okay. Moving on to the next thing. I think this is clear to all of you guys. Okay. And over here also the answer was coming out to be minus iota. I said okay. What is the real part of this particular complex number? Okay. This expression can be written as 1 plus iota square. Iota square is, by the way, minus 1. So this can be rewritten as 0 plus I. Yes or no? Now the term which is written without I in it is the real part of the complex number. That is, real part of the complex number over here is going to be 0. And the term which is written along with I, the term which is written along with the I is known as imaginary part. So along with I, 1 is written. So that's why 1 is the imaginary part. I would like to tell you a very important point over here, that both real part and imaginary part of the complex numbers are real numbers. If let's say a complex number is this, then the real part is going to be 3 and the imaginary part is going to be 4. Yes or no? The imaginary part is not going to be 4i. Again, I am repeating, it is going to be 4 only. So real part of a complex number and imaginary part of a complex number are both real numbers always. Okay. Yep. So over here, the real part is coming out to be 0. I think the problem is clear to all of you guys. Yep. Okay. Now over here, if you see, this is iota to the power 0 plus iota to the power 1 plus iota to the power 2 plus iota to the power 3 plus iota to the power 4 plus iota to the power 5 plus iota to the power 6 plus iota to the power 7 and so on. Terms like this are given. Okay, we know that summation of any 4 consecutive powers of iota is equals to 0. So this summation is what we want to find out. This summation is going to be 0. This summation is going to be 0. And like this, if you will move on, you can see that how many terms are written over here? 2016 number of terms are written. Because we are starting from 1, that is we are starting from iota to the power 0. And we are going till iota to the power 2015. That's why we can say that over here 2016 terms are written. If we make a group of 4 like this, don't you think that all the terms will be consumed over here? Yes or no? So over here iota to the power 2013 plus iota to the power 2014 plus iota to the power 2012 will come in the last group, and that is again going to be 0 only. So 0 plus 0 plus 0 plus 0, you're gonna get nothing but 0 as the answer only. Because if you form a group of 4, all the 2016 terms appearing over here will be consumed, and that's why the answer is coming out to be 0. You can check it out over here. I have explained this. I hope the problem is clear to all of you guys. Okay. Talking about this particular problem, if a square plus b square is equals to 1, then the value of this expression is going to be what? I think this question should come a bit later, but as you have already studied this topic, you guys can do it on your own. Or let me tell you one objective trick, that if you want to find out this particular thing, then we should always try to solve such kind of questions by using objective trick, because that is a very important learning. Let's say that if we take a as 0, and since objective trick I'm talking about, subjective I think you guys can do it, or I'll discuss it later as well. Objective method I want to discuss as of now. That if a is equals to 0, then from this equation the value of b can be either 1 or minus 1. Let's say the value of b is minus 1. Okay. Now in that case, the complex number this is going to be how much? 1 plus 1 plus 0 divided by 1 plus 1 minus 0, that is equals to 2 upon 2, that is equals to 1. Yes or no? So in which of the following options this can be our answer? Okay, this will never be our answer. B is 1 and a is 0, so this can never be, this can also be our answer. Because when we put b as 1 and a as a 0, this is also giving us 1 only, and this can never be our answer. So at least out of the 4 options, we have eliminated 2 options in a matter of few seconds only. I said fine, okay, no issues. Now, if a is 0, then b can also be minus 1 from this particular equation. Yep. Okay. In that case, if you are taking b as minus 1, so denominator is going to become 0. So that is not possible. Let's take any other value. Let's take any other value. Let's say a is equals to 1 you have taken, and this time b you are taking as 0. So in that case, this expression is going to be how much? It is going to be 1 plus iota divided by 1 minus iota. So this expression can be further simplified. I hope you know the thing. So this is going to be how much? 2, and this is going to be 2 iota. So 2 and 2 cancelled. So this is going to be iota only. So which of the following option gives you iota? The option A, no sir. This one, yes. So that's why C for Calcutta is the correct answer. Now look, by using just few values, we have eliminated the options. And I think if you proceed in this question subjectively, it is going to take a lot of time. Yes or no? So I think the problem is clear to all of you guys. All right. Talking about this problem, iota is equals to under root of minus 1. Sigma of this particular thing is what we want to find out. Sigma means summation. Okay, we have to go from n is equals to 1 to n is equals to 13. That means once we need to put n is equals to 1 into this. If you put n is equals to 1, it is going to look like this. Okay, then we need to put n is equals to 2. So it is going to look like this. Then we need to put n is equals to 3. It is going to look like this, and so on. We're going to proceed. Yes or no, beta? Okay, and ultimately we have to put 13 in place of n. So this is what we are having as of now. I said fine, okay. Keeping taking the first terms, these terms together, we can write it over here, iota plus iota square plus iota to the power 3 and so on till iota to the power 13. Okay, then writing down these terms together, the terms which are coming later over here, iota to the power 2 plus iota to the power 3 plus iota to the power 4 and so on till iota to the power 14. Now over here, look, 13 consecutive powers are written. So if we make a group of 4, then only iota to the power 13 will remain, because rest, okay, these are 13 terms. So iota to the power 13 will remain, rest everything is going to be 0 only. And over here, if you see, these are also 13 terms written, because we are starting from 2 and going till 14 only. So until 12th term, if you see, the summation is going to be 0, because sum of any 4 consecutive powers of iota is nothing but 0 only. So this is going to be a required answer or not. If this is the case, then iota to the power 13 is nothing but iota, and iota to the power 14 is nothing but iota square. So the answer can also be written as iota minus 1, sorry. Iota minus 1. So iota minus 1 is the answer. That means A is the correct answer. I don't think there has to be any confusion in this particular question. Yes, the correct answer is A for Arvind sir. Yep. Okay. You just need to deal with sigma. I hope you know that. In case you don't know, then we will cover this sigma thing entirely in the chapter sequence and series one shot. So don't forget to watch that as well. If alpha and beta are the roots of this particular equation, now there are numerous ways to find out the roots of this particular equation. One way is method 1 to find out the roots is Sridharacharya method. Another method is we can do it like this: x square minus 2x plus 1 equals to 0. By this we can create a perfect square, and like this we can write down. So over here the equation becomes something like this. This can further be rewritten like this. This can further be rewritten as x minus 1 equal to plus minus iota. So over here x is nothing but 1 plus minus iota. So alpha we can take as 1 plus iota, beta we can take as 1 minus iota. These are our two roots. So one method of finding out the roots alpha and beta is like this. I hope this method is clear to all of you guys. Okay, then we need to find out the least value of n for which alpha by beta, that is this particular thing, is equal to 1. Least value of n we want to find out. I said, okay, let's rationalize it. So the moment we rationalize it, or we do the division of the complex number, then this is what we're going to get. So over here, if you see, it is going to be nothing but equal to iota to the power n is equals to 1. So the least value of n is going to be 4. The least value of let me tell you over here one more thing. The least integral value, the least natural number. The least natural number for which this is equals to 1, because if it is least whole number, then the answer would have been 0. Yep, I think the problem is clear to all of you guys. Okay, talking about this, x to the power 4 plus 4 equals to this. Now there are multiple ways to solve this. Okay, let me tell you this. X to the power 4 plus 4. Okay, we can write down this particular thing as x to the power 4 minus of minus 4. Then we can write down this thing as x to the power 4 minus 2 iota ka whole square. Then we can apply a plus b into a minus b, or a square minus b square equals to a plus b into a minus b. Yes or no, kids? So this can further be written as x square plus 2i times of x square minus 2i. Yep. Okay. Then again we can split this one, and then we can move accordingly, and we will be able to proceed like this, and the problem can be solved. Okay. One way is this, but let's say this question comes objectively in your examination. Okay. Let's say this question has come objectively in your examination, and I hope you have studied a bit of the complex numbers. Let me tell you that if a complex number x comma y is the point x comma y in the Cartesian plane, where this distance is obviously x and this distance is y, then the same point in the Argand plane is going to be x plus iy. Yes or no? If you know this much, then let's say you have been told that x to the power 4 plus 4's value is going to be what? And this is option A given to you. So you can solve your question in just a matter of few seconds itself. You just need to you need to find out the value of this, and you can evaluate the value of this at x equals to 0. At x equals to 0, this expression is how much? At x equals to 0, the value of this expression is 4. Can we find out the value of this, the value of this expression at x equals to 0? Yes, definitely, because that is equals to 1 plus iota times of 1 minus iota, then minus 1 plus iota times minus 1 minus iota. So over here, a plus b into a minus b, this is going to be 1 minus iota square. And this is going to be 1 minus iota square again. So this is going to be how much? This is going to be 1 minus 1, 2. And this is also going to be 2. So 4, this option is also giving us 4. So this can be our answer. Like this, objectively, we can proceed and we can solve the question. If you want to solve it subjectively, it's not a big issue. Let me tell you, I have attached the solution as well, and I'm explaining it a bit as well. This and this will be multiplied. So a plus b into a minus b, considering this as a and this is b. So this is a plus b into a minus b. It is going to be a square minus b square. And similarly over here, if you see that we are taking this thing as a and this thing as b, this thing as a and this thing as b. So again over here also it is a plus b into a minus b. So we can write it as a square minus b square. Yes or no? Yep. Okay. Iota square is nothing but plus 1 only. So we have written it. Then over here iota square is also equals to minus 1. So we have put it. And then I don't think there has to be any confusion, because once again over here if you see this term and this term can be collectively taken as a, and this term can be taken as b. And similarly a plus b into a minus b, again we apply, we will get this kind of a result and the problem is solved. So subjectively, if the question we want to solve, we can solve it in this way as well. There can be numerous methods. The kids will say, sir, can we directly multiply them? Yes, you can directly multiply them as well, but that is going to be a bit lengthy. That's why I have told you these two simple methods which you always need to keep in your mind. Okay. Now talking about equality of complex numbers, let me tell you one thing, that inequality is not defined in complex numbers. Any complex number cannot be greater than or lesser than any another complex number. Inequality is not at all defined. Equality of complex numbers, let's say a complex number z1 is there, a plus ib, where a and b are real numbers. Okay, let me tell you, a, b, c and d are real numbers. And z2 is another complex number, c plus id. Okay, then if z1 and z2 are equal complex numbers, then that means the real part of the complex numbers, that is a and c, both are equal, and also the imaginary part of the complex numbers b and d are also equal. If the real part of the complex number is equal to real part of another complex number, and imaginary part of the complex number is equal to another complex number's imaginary part, then only the two complex numbers will be equal. Okay. Now over here, if it is given to me that x and y are real numbers, and I want to find out and it is given to me that these two complex numbers x plus iy and 3 plus 4i are equal, then we can directly tell the value of x and y as x equal to 3 and y equal to 4. If this is the thing given to me where x and y are real numbers, then 2 can be written as 2 plus 0i. So the value of x is going to be 2 and the value of y is going to be 0. If this is the thing given to me, then I can write it as 0 minus 2i or 0 plus of minus 2i. Then in that case, x is going to be 0 and y equal to minus 2. And if this is the thing given to us, then 0 can be written as 0 plus 0i as well. So the answer is going to be both x and y being equal to 0. Now let me tell you one very important thing. If I give you a complex number like this, let's say something like this, p plus iq. And if I ask you what is the real part of the complex number p, what is the real part of the complex number this? A lot of guys will tell me that the real part of the complex number is p and the imaginary part is q. And let me tell you, you are wrong. The real part of the complex number is not p until and unless p and q are given as real numbers. If p and q are given as real numbers, only in that case you can say that the real part of the complex number is p and the imaginary part of the complex number is q. Only in the case when p and q are given to you as real numbers. Why? Let me give you an example. If I give you a complex number like this, now if you compare it with p plus iq in the previous problem, and I haven't told you that p and q are real numbers, so in that case the value of p will be this, And this can never be real part of the complex number. Yes or no? Because real part of the complex number does not have I in it. Yes or no? So look, if P plus IQ is given and it is not given to you that P and Q are real numbers, then you cannot take real part of the complex number as P and the imaginary part of complex numbers as Q. You cannot take that. Only in the case when P and Q are given to you as real numbers, then only you can say that real part of the complex number is going to be P and the imaginary part of the complex number is going to be Q. I hope the point is clear to all of you guys. Okay, let's talk about this particular problem. Whenever you are given some short equations in complex numbers, that is the equations like this, one thing that you have to keep in your mind is you have to put z is equals to x plus iy, where x and y are real numbers. The moment I have said that x and y are real numbers, I can say that the real part of the complex number is x and the imaginary part of the complex number is y. Okay, let's put it over here. So the moment you put it over here, the value of z square will be what? X square minus y square plus 2ixy minus 1's modulus is equals to x square minus y square plus 2ixy plus 1. Yes, okay. Let's write down the modulus values of these two expressions. I hope you know the modulus. Under root of x square minus y square minus 1 का whole square plus 2xy का whole square equal to, over here it is going to be under root of x square minus y square का whole square plus 2xy का whole square plus 1. Squaring both sides, if you do square both sides, then it is going to be x square minus y square minus 1 का whole square plus 4x square y square equal to, over here if you do square, then it is going to look something like this. Okay, plus 1 plus twice of under root x square minus y square का whole square plus 2xy का whole square. We have done squares on both the sides. So over here it is going to be a plus b into a plus b का whole square, right? Okay. The moment you do this, x square minus y square plus 1 minus 2 times of x square minus y square plus 4x square y square equal to this thing on the right hand side, writing it as it is. The expression is going to look something like this, kids. Right, over here if you see, then these terms gets cancelled, these terms gets cancelled, so we are left out with 1 minus twice of x square minus y square is equals to twice of under root x square minus y square का whole square plus 2xy का whole square. Yep. Okay. Moving ahead. Squaring once again. 1 plus 4 times of x square minus y square का whole square minus 4 times of x square minus y square is equal to 4 times of x square minus y square का whole square plus 4x square y square will come over here. I said okay. Then if you see closely over here, you will observe that this can be further rewritten as something like this. Four times of x square minus y square का whole square plus 16 times of x square y square. So over here if you see, bete, then this term and this term is cancelled. So you are left out with something like this. Yep. Okay, if this is the case, then what kind of an equation is this? This is not a parabola. Why? Because now you have studied conic sections. So from conic sections, you can have an idea what kind of a thing it is going to be. Yep. What kind of a thing it is going to be, you can have an idea and then you can mark it. Let me tell you that this is not an ellipse, because in an ellipse you might have observed that the coefficient of x square and y square are both positive. In the ellipse, in the parabola, one power is 1 and another variable's power is 2. So this is not the answer. In a circle, coefficient of x square and coefficient of y square are both equal. So rather it is a hyperbola. So the answer has to be D for Delhi. So this is rather a hyperbola, right? This is rather what? This is a hyperbola. Okay. Yep. All right. Talking about this is a JEE Main 2019 question. Let's try to solve this. Equality of complex numbers. Okay. I said fine. Taking the LCM over here, we can write it down like this. Then the expression is going to be minus times of 6 plus iota ka whole cube divided by 27 is equal to x plus iy equal upon 27. 27 and 27 are cancelled over here. So it is going to be minus x minus iy equal to 6 plus I ka whole cube means 6 ka cube, that is 216, plus iota ka cube, that is minus iota, plus 3 AB means 18 iota times 6 plus iota is what we're going to write down. Okay, then the same expression can be written as 216 minus iota plus 18 times 6 is 108 iota minus 18. Okay, so over here minus x minus iy can be written as a plus b ka whole cube is equals to a cube plus b cube plus 3ab a plus b, right? Okay, 3ab 3ab a plus b. Okay. Yep. So this is going to be how much? 198 plus 107 iota. So over here, if you compare, the value of minus x is minus 198 is 198. That means the value of x is minus 198. And the value of minus y is 107. That means the value of y is 107. Now the question is asking you what? The question is asking you the value of y minus x. Y minus x. So the value of y minus x is going to be what? Plus 198. So that is going to be 91, I guess. Yes. So 91, that is option A, has to be the correct answer. I don't think that there is any confusion in this particular question. Yes, the problem was very easy category of problem asked in. Yes, it is a bit calculative, that I do understand, but if you are preparing for JEE, then you should be able to solve these kind of problems in the JEE examination. The calculation part is what you have to focus on. Okay, talking about this, let's say I want to plot 4 plus 3i complex number on the plane. Then this is nothing but the same point 4, 3. On the real part, you have to move 4, and the imaginary part, you have to move 3, right? The complex number 1 plus iota is same as 1, 1. Right? Yes. That means on the x-axis you have to move 1. On the imaginary axis you have to move 1. That's it. Right? Yep. Distance of P from origin. This is nothing but the, let's say any complex number z is equals to x plus iy is there. Then the point P comma y is nothing but that complex number only. So the distance of that complex number from origin is nothing but the modulus of x plus iy. I hope that in class 10th you have learnt distance formula. So if you want to find out the distance between P and O point, that is having coordinates x comma y and 0 comma 0, then the distance formula can be rewritten as under root of x minus 0 ka whole square plus y minus 0 ka whole square, which is again equal to under root x square plus y square only. So that is nothing but modulus of the complex number z. So mod z is nothing but equal to under root x square plus y square only. X is what? Real part of the complex number. So that's a square, and y square is nothing but imaginary part of z ka whole square. So this is called as the modulus of z, that is distance of the point P from the origin. Find the distance of 1, 1 and 0, 0. So that is going to be root 2. So this is nothing but the distance of the point from 1, 1 to 0, 0. So if we write down this complex number, then the complex number z is nothing but 1 plus 1i, and its modulus is nothing but equal to root 2, right? I hope this thing is clear to all of you guys. Okay, so root 2 is the distance coming between these 2 points, and also if we say what is the modulus of the complex number 1 plus iota, that is again equal to root 2 only. Okay, talking about this, finding out mod z in this case. So here mod z can be written as under root of real part ka whole square plus imaginary part ka whole square. So that is equals to under root 1 plus 1. So that is again equal to root 2. Okay, talking about this, mod z is equals to under root of root 3 ka whole square plus minus 3 ka square. So that is going to be 3 plus 9, that is equals to root 12, and root 12 is nothing but 2 root 3. So I hope you guys are clear with finding out the modulus in this fashion. Now understand, this complex number is also having modulus root 2, and this complex number 1 plus iota is also having modulus root 2. So there can be multiple complex numbers having same modulus, right? Okay, I hope this point is clear to all of you guys. Explaining properties of modulus of complex number, you can consider this sign as of modulus only or vertical bars. Okay, the modulus can be splitted in multiplication. Let's say one complex number z1 is given to me like this, 3 plus 4i, and another complex number z2 is equals to 1 minus iota given to me, and the question is asking me the modulus this. So an easy way to solve this is, one way will be like this, that z1 is given to you, z2 is given to you, multiply these two. First find out the complex number and then find out its modulus. But another way is what? This identity, that is, this can also be written as mod z1 into mod z2. Now understand, it is very easy to find out mod z1 because that is under root of 3 square plus 4 square, that is 5, and this is root 2, so the answer has to be 5 root 2 only. So without even finding z1, z2, we can find out the modulus of z1 and z2 by using this property. Similarly, if I want to find out this, one way is to find out z1 by z2 modulus. One way is first finding out z1 by z2, and then once you have got the modulus, once you have got the complex number z1 by z2, then you find out its modulus. That is going to take a lot of time. So rather we will use the property this, that the modulus can be splitted in division. So we will write down this as 5 by root 2. So this is our modulus, right? So whenever, understand, two things are there. Whenever two complex numbers are written in multiplication or two complex numbers are written in division, and we want to find out the modulus of the entire thing, then we can split the modulus like in these two things. Okay, number 3. In general, modulus of z1 plus z2 is not equal to z1 mod z1 plus mod z2. The same things apply to negative as well. Mod of z1 plus z2 is always not equal to mod z1 plus mod z2, because in vectors you might have seen that mod of a vector plus b vector may or may not be equal to mod a plus mod b. Yes or no? So same thing is there with the complex numbers as well. In general, these two things are not equal. They can be, but only for a certain values, but not in general. Whereas if multiplication and division are there, then the modulus can be splitted like this. Okay. Yep. If any positive number k is given to me and I have to multiply that with z1 first, and then we have to find out the modulus. The same thing we can do by taking the modulus of k as outside and then taking just the modulus of z1. Let's say if I say you over here that z1 is this and find out this modulus of this particular thing, you can simply take this 2 outside and multiply it with the modulus of z1. So in that case, it is going to be 2 times of 5, that is equals to 10. I hope you understood this property. Okay. Now talking about the fourth one is a special case of 1. Let me tell you that as well. If Z1 into Z2 into Z3 and so on, multiple complex numbers are there, and we need to find out the modulus of this, then by using the property 1, we can write it as mod Z1 into mod Z2 into mod Z3 into mod Z4 and so on till mod Zn. Now assume that Z1, Z2, Z3 are all same, Z only. So Z into Z into Z into Z m times will be equal to what? Mod Z into mod Z into mod Z into mod Z m times. So that will be equal to mod Z to the power m or not. So if I tell you to write down this particular thing, then you can find it out like this in an easy manner, right? I hope this identity is clear to all of you guys. Okay. For a positive real number, that means what? Imaginary part is 0. If the imaginary part is 0, then let me tell you one very important thing over here, that mod of Z will be equal to Z only if it is a positive real number. Can you feel it? Because let's say the complex number Z is equals to x plus iy, where x and y are real numbers. Okay, and then I'm taking that y equal to 0 and x greater than 0. So Z is going to be purely positive real number. So the modulus is going to be same or not? Yes, this is what it is given over here. And if Z is a negative real number, then the modulus of Z is always greater than equal to 0 only, because a distance is always positive only, that's why. So if it is a negative real number, then that means minus of x will become positive in that case, because x is negative, right? Okay. So mod Z, if Z is given to you as x plus iy, if let's say this kind of an equation is given, under root x square plus y square is equals to x plus iy, or mod of Z is equals to Z is given to you. Now this is a simple equation, so we simply need to put Z as x plus iy. On comparing, we will get these kind of results, and accordingly we will be able to get the thing done, right? Okay. Moving ahead, let's say if you want to find out the modulus of this. Now one way is what? Method 1. That is going to be a bit lengthy, which a lot of guys used to do. 1 plus iota upon 1 minus iota. What we're gonna do? 1 minus, we will multiply in the numerator and denominator 1 plus iota. Then it is going to be 1 plus iota ka whole square. It is going to be 1 square plus 1 square. So it is going to be 2 iota over 2. That is iota. One way is this. And then finding out the modulus of that. Modulus of iota is equals to 1. Another way, method 2 is, since we want to find out the modulus of Z, so let's take the modulus on both the sides. Now, modulus can be split in multiplication and division. Over here, division is there, so we can split the modulus like this. And we know that this is also root 2 and this is also root 2. So this is equal to 1. That's it. This way it is going to be way easier, because there is going to be less calculation, people. Okay, let's talk about this. If we solve it by method 2, then mod Z will be written as mod of 1 plus iota ka square. Now this can further be written as 1 plus iota into 1 plus iota. And we know that if in between two complex numbers multiplication is written, then we can split it. So we can write down the question like this as well. Now this is also root 2, this is also root 2. So this is how much? 2. Yes, the question is done. Yep, I hope the problem is clear to all of you guys. Okay, if you want to find out the modulus of this, then this can be written as 1 plus iota times 1 plus 2 iotas modulus times 1 plus 3 iotas modulus. So this is going to be root 2, this is going to be root 5, this is going to be root 10. Yes or no? So this can be written as under root 100. Under root 100 is nothing but equal to 10. So 10 is the answer. Yep. Anyone is having any confusion in this? I don't think there has to be any. Okay, moving ahead. Z is equals to x plus iy and p is equals to this. Show that the modulus of p is equals to 1, then Z is real. Show that if modulus of p is equals to 1, then Z is real. Okay, over here let me tell you x and y are real numbers. This should be given. Okay. Okay, let's try to solve this question. Modulus of p is given to me as 1, so we can say that mod of p can be written as 1 minus iota z divided by z minus iota's modulus. Now this is given to me equal to 1, so I said fine. We can write down the expression like this as well. We can split the modulus whenever multiplication and division of the complex numbers is written. If you want to find out the magnitude of this complex number, then this can be written as 1 minus times of x plus iy. And over here it can be written as x plus iy minus iota, taking the real parts together and imaginary parts together. So iota square is minus 1. So it is going to be 1 plus y plus iota x divided by, this one is going to be how much? This one is going to be x plus y minus 1 iota. Okay. Yep. So if this is the thing given to me, or we can do multiple ways as well. I'll talk about that as well. Okay. So this thing can be further rewritten as 1 equal to 1 plus y plus iota x's modulus divided by x plus y minus 1 times iota's modulus. So if we cross multiply, then the two things are going to be same. If these two things are same, then their squares will also be same. Yes or no? So if this is the case, then their squares are also going to be same. If their squares are same, then this can be written as x square plus y minus 1 ka whole square. This can be written as 1 plus y ka whole square plus x square. So if you expand this, it is going to be x square plus y square minus 2y plus 1 equal to y square plus 2y plus 1 plus x square. The terms can be cancelled. Few of the terms can be cancelled over here. So y square, x square cancelled. So over here 1 and 1 also cancelled. So you can say that 4y equal to 0 means y equal to 0. And if y is equal to 0, then the complex number z is going to be what? Since we have got y as 0, so the complex number z is going to be purely real only. Yes. Anyone is having any kind of confusion in this, feel free to reach out to me. Yep, understood. Okay, let me tell you method 2. Let me tell you method 2 as well. Method 2. P is given to me as 1 minus iota z divided by z minus iota. And it is given to me that mod of P is equals to 1. I said, okay. If we multiply iota in both the sides, then it is going to look something like this, beta. Okay. Then P times of I is equals to, this is going to be how much? I minus iota square z divided by z minus iota. So this can further be written as P iota equal to iota plus z upon z minus iota. Yes or no? Yep. Okay. And then if you proceed, if you take the modulus of on both the sides, then this is going to be mod P into mod iota is equal to mod of iota plus z upon mod of z minus iota. So these are both 1 1 only. I hope you know that mod of iota is also 1. So doing that, we're gonna get something like this. So from here also you can say that this has to be, z has to be real number only, because now you can now put z is equals to x plus iy. A lot of calculations will be solved, will be done away with if we proceed it like this, right? Okay, so this is the method I have attached for you guys in the subjective form as well, but I don't think that you will require this. I think definitely you can solve the question on your own. Okay, talking about the next thing. If x plus iy equal to under root of this, then prove that this kind of a thing. Now understand, x plus iy is there, and from there we need to move to x square plus y square. Whenever from x plus iy to x, we want to move from x plus iy to x square plus y square, we need to take modulus on both the sides. Yes or no? Okay. So the moment we take modulus over here, it is going to be something like this, and over here it is going to be under root of a plus ib divided by c plus id's modulus. So it is going to be under root x square plus y square on the left hand side, and over here it can be written as under root of a plus ib modulus, and then modulus of under root c plus id. Okay, then if we square, it is going to be x square plus y square. Over here, this under root can be taken away because z to the power m ka modulus is equals to mod z ki power m. Yes or no? So we can write it down like this. And also we have squared, so we can write it down like this now. So over here, this can further be rewritten as under root a square plus b square, and this can be written as under root c square plus d square. So now squaring once again, you will get this particular expression. Yes or no? Everyone have a look at this. So whenever we want to move from x plus iy to x square plus y square, you need to understand that you have to take modulus. That way you will definitely be able to reach to that particular point. Okay. Yep. If z1 and z2 are two complex numbers, then modulus of z1 plus z2 is always less than or equal to mod z1 plus mod z2. Now this is triangle inequality. This is same as it happens in vectors as well, because if they are in the same direction, then mod of z1, mod of a vector plus b vector will be equal to mod a plus mod b. Remember, if the vectors are in opposite sign, then mod of a plus b will be equal to mod a minus mod b. Remember. Yep. So same thing is there in the complex numbers as well. In physics, you might have studied this. I'm connecting it with complex numbers. But you need to remember this, as it is a very, very, very important identity. Remember this. Okay. Yep. All right. Also, a few more identities are there. This one, and this is the crux of 1 and 2, by the way. This is nothing but the combination of 1 and 2. Combination of 1 and 2. Okay, so you should keep this thing in mind as well. Okay, now talking about this problem, if mod z1 is equals to 2, now let me tell you how many complex numbers are there z1 for which its modulus ka value will be equal to 2. If we put z1 as x1 plus iy1 or x plus iy, let's say, then we can say that mod z1 can be written as under root x square plus y square equal to 2. Then this same thing can be written as x square plus y square equal to 4. Yes or no, beta? That means what? This is a circle having radius 2. So z1 can lie anywhere on the circle with radius 2. Yes or no, everyone? Do let me know. z1 can be any circle with radius 2. So this point 2, 0, this point minus 2, 0, this point 0, 2, and this point being 0, minus 2. Not just this, but over here some point root 2, root 2 will come. Over here root 2, minus root 2, root 2 will come, and multiple points 1, root 3 and so on. All these points will be lying on this circle, don't you think? Now z1 can be any point out of the points on this circle, because mod z1 is equals to 2 given to us. Yes or no? Okay, then this particular thing. Now there are numerous ways to solve this question. Let me tell you the method number 1. Okay, let me tell you the method number 1. What are the things given to us? The things given to us are mod z1 is equals to 2, and what we need to find out is z1 plus 5 plus 12i, mod of z1 plus 5 plus 12i is less than or equal to what? Is less than or equal to what? Okay, this is what the question asking me. Okay, now understand. Mod of z1 plus z2 is lesser than or equal to mod z1 plus mod z2. Yes or no? Okay. Now, this value is always lesser than this. So, if we compare this and this, we can feel that z2 is nothing but 5 plus 12i. Yes or no? So, if we keep this over here, so z1 plus 5 plus 2i will be less than or equal to mod of z1 plus mod of 5 plus 12i. Yes or no? So this value will be lesser than or equal to 12 plus 13. I hope you can calculate the modulus of this. Under root 5 square plus 12 square, that is 13. So this is coming out to be less than or equal to 15. That's it. So this value is always less than or equal to 15. So the answer has to be D for Delhi. So one way is this, the identity you guys know, and you have to make use of the identity. One method is this. Method 2, let me tell you that. Method 2. Mod of z1 is equals to 2 given to us, and the question is asking us this value is less than or equal to what? right? So we can do it geometrically as well. First, we can draw a circle Z1 having radius 2. This is the circle for this particular thing. Okay. And I hope you guys know that mod of Z1 minus Z2 is nothing but distance between complex numbers Z1 and Z2. Distance between Z1 and Z2. So if I'm talking about Z1 plus 5 plus 12i, then this can further be written as mod of Z1 minus 5 minus 12i. That means this can further be rewritten as the distance between Z1 and minus 5 minus 12i. Minus 5 and minus 12i will be lying somewhere over here. Minus 5 minus 12i. That is minus 5 comma 12. Yes or no? Now Z1 lies anywhere on the circle. Lies anywhere on the circle of radius 2 and center 0 comma 0. Yes or no? So I hope you guys remember that the shortest distance lies along the common normal. How many of you guys know about this? The shortest distance lies along the common normal. And over here greatest as well. So this distance is going to be the shortest one, and the distance between this point and this point is going to be the greatest one. So over here it is asking me the distance is less than or equal to. The distance is less than or equal to means we have to find out the greatest distance. So we have to find out the greatest distance between these two things. Okay, number one, we can find out the distance between this and this, that is 13, between origin and minus 5 comma minus 12. Okay, in that if we add the radius of the circle, that is 2. Don't you think that we will get the farthest distance between point minus 5 minus 12i and the point on the circle? That is 13 plus 2, 15. That's it. Geometrically, the question is solved. Try to solve these kind of questions geometrically, because if you have a good command over geometry in complex numbers, then it will automatically reflect into coordinate geometry as well. Like the topics like parabola, ellipse, hyperbola, circle, straight lines, you will be able to command over those topics as well, because ultimately the things are same, only the way of writing is different. So try to have a good command over that. Okay. Yep. Argument of a complex number. Now look. Let's say a complex number x plus iy is there. We can show the same point as x comma y. Okay, and if we connect it with origin, the distance between origin and that particular point P is nothing but modulus of the complex number z. Now, if we see that line segment is forming an angle with the x-axis, yes or no? So that angle is nothing but the argument of that complex number. If that angle is taken from minus 180 degree to 180 degree. Or we can say minus pi to pi. If we are taking the angle formed by the line joining the complex number and the origin with the positive direction of x-axis, that is nothing but the argument. Okay, the argument, principal argument goes from minus pi to pi. Principal argument goes from minus pi to pi. Okay. Yep. So this is the process. Let me tell you that process. Steps to find out the argument of a complex number z. These are the steps. First, you take the complex number z is equals to x plus iy. Obviously, x and y are real numbers over here. Okay. Then you first find out the value of theta equal to tan inverse mod of y by x. Now, identify the quadrant in which z lies. Look, in the first quadrant, x and y both are positive. In the second quadrant, x is negative, y is positive, yes or no? In the third quadrant, both x and y are negative. In the fourth quadrant, x is positive and y is negative. So let me tell you one example. Let's say I tell you a complex number is 1 plus root 3 iota. So first you will find out step 1. First you will find out theta is equals to tan inverse mod of y by x. So it is going to be tan inverse root 3. Now, can you tell me for which angle the value of 10 comes out to be root 3? For which angle the value of tan comes out to be root 3? Pi by 3. So, theta is nothing but pi by 3. Number 1. Step 2 is find out the quadrant in which this complex number lies. So, over here x and y both are positive, means first quadrant. Now, the moment you have identified the quadrant, these are the formulas. These are the things. Okay, let me tell you. Let me do some correction over here. This is minus pi plus theta. This is pi minus theta. Okay. This is pi minus theta. This is minus pi plus theta, and this is minus theta only. Okay. Yes, these are the formulas. These are the formulas. If the complex number is lying in the first quadrant, then theta is the argument. If the complex number is lying in the second quadrant, then pi minus theta is the argument. Then if the complex number is lying in the third quadrant, minus pi plus theta is the formula. And if the complex number is lying in the fourth quadrant, then minus theta is the thing. Okay. Yes. Let's say over here it is first quadrant only. So for the first quadrant, theta is the argument. So theta is equals to pi by 3 is the principal argument. If let's say I would have given 1 minus root 3 iota as the complex number, then in that case step 1 would have been same, because tan inverse mod of minus root 3 upon 1, it will be same, pi by 3 only. Okay. Step 2, x is positive and y is negative. In that case, x is positive and y is negative means this will be the quadrant. So in that quadrant, the formula for the principal argument is what? Minus theta. So the answer would have been minus pi by 3. Right? Yes. So these are the steps to find out the argument. Okay. If either of x or y is 0, then do not use this method. Instead use these values. Okay. We can say that if it is on the real positive x-axis, then the argument will be 0 or 2 pi. If the point is lying on the real negative x-axis, like the points like 0, 0 minus iota, for these points, the argument is pi or minus pi as well, we can say, or minus pi. The principal argument is though minus pi. Purely imaginary positive numbers means the complex numbers are here, here, here. The argument is going to be pi by 2. And here it can also be written as minus pi by 2. Right? So these are the examples given to you. You can consider all these. Right? Okay. Now we want to find out the argument of this. The first step one, theta equals to tan inverse modulus of 1 upon minus 1. So it is going to be tan inverse 1. Tan inverse 1 is nothing but pi by 4. Okay. Step 2 is x is negative, y is positive. X is negative and y is positive means which quadrant? Second quadrant. So if we have got second quadrant, then the formula in the second quadrant is what? Pi minus theta is the principal argument. So pi minus pi by 4, that is the principal argument is what? 3 pi by 4. I hope the problem is clear to all of you guys. Yep. Okay. Moving on to the next thing, argument. In this case, if you want to find out, then theta is step 1. Theta equals to tan inverse of minus 3 by root 3. So it is going to be tan inverse of root 3 only. So for what angle the value of tan comes out to be root 3? Pi by 3, I guess. Yep. Okay. Step 2 is identifying the quadrants. X is positive, y is negative. X is positive and y is negative means it is fourth quadrant. And in fourth quadrant, the formula for argument was what? The formula for argument was minus theta. So that means minus pi by 3 is the principal argument. Anyone is having any confusion in this? There has to be none. Right? Okay. Moving ahead. What is the principal argument of a complex number? As I just told you, let me tell you the argument and principal argument. Okay. Yep. If let's say a complex number is represented over here. So this line is making an angle theta with the positive x-axis. So this same theta, this same direction can be represented by theta or 2 pi plus theta. It can be represented by 4 pi plus theta. It can be represented by 6 pi plus theta. So theta, 2 pi plus theta, 4 pi plus theta, 6 pi plus theta, and so on. Not just this, but also minus 2 pi plus theta, minus 4 pi plus theta. These are all same directions. Means the argument can be infinite. Means argument can be infinite. That is yes or no? But out of these infinite arguments, principal arguments are the arguments which goes from of a complex number is unique because it goes from minus pi to pi. It goes from minus pi to pi, including minus pi and excluding pi. Okay. Yes. So arguments are infinite, but principal arguments are unique. So argument of a complex numbers depend upon the quadrant in which it lies. In place of taking a long route lying in the third or fourth quadrant, we take in the clockwise direction. That's why we are going till minus pi. I hope you have learned this in trigonometry, right? Okay. So principal argument, these are the formulas, right? I have already told you these formulas, so there has to be no confusion at all. Okay, the principal argument of these we have already got. I don't think there has to be any issue in these examples. Explaining the properties of argument of logarithm, argument of complex number. Then argument behaves like argument follows the property of logarithms. I hope you have learnt in logarithm that log A plus log B with the same base CC is equals to log AB to the base C. Number 1. Number 2, log A to the base C minus log B to the base C can be written as log of A by B to the same base C. Number 3, log of A to the power M to the base C can be written as M times of log A to the base C. Yes or no? Over here also the same formulas are there for the argument. Let me tell you this. Argument of z to the power m, this m can be taken in front, can be written like this, m times of argument of z, like the property 3. Keep this 2k pi separate as of now. Argument of z1 into z2 can be written as argument of z1 plus argument of z2, like in the property 1, and argument of z1 by z2 can be written as argument of z1 minus argument of z2. Okay, but these argument we would like to bring in the principal domain, that is between minus pi by 2 pi, minus pi to pi. That's why these 2k pi's are added, so that we can bring that into principal domain whenever it is not coming in the principal domain, right? I hope you guys are clear with this. Let's do some problems based on the properties of complex numbers to identify it better. Okay, yep. Let me tell you it over here. Argument of, let's say I want to find out the argument of 1 plus iota upon 1 minus iota. Now one way is what? Method 1 is that we can first simplify this complex number. 1 plus iota, this 1 plus iota ka multiplication in the numerator and in the denominator as well. Then this thing can be written as 2 iota upon 2. This thing can be written as argument of iota and argument of iota. If you evaluate, you will come to know that it is pi by 2. So this is method number 1. But what am I teaching you is the property over here. So let's understand that. Argument of z1 by z2 can be written as argument of z1 minus argument of z2 plus 2k pi, where k belongs to an integer. I said okay. Can we find out the argument of this? The argument of this is going to be pi by 4 and the argument of this is going to be minus pi by 4 plus 2k pi. So this is going to be how much? Pi by 2 plus 2k pi. Now understand, if what value of k we should put over here so that this value comes out to be in the principal argument, that is minus pi to pi. We should take k equal to 0 so that this value is coming between minus pi to pi. That's it. The question is done. So pi by 2 is the principal argument, right? So using the properties of argument, the problems can be simplified in a relatively easy manner. Okay, let's say I want to find out the argument of 1 plus iota to the power 10. Argument of 1 plus iota to the power 10. Now one way is what? Multiplying it again and again and again, right? 1 plus iota, 1 plus iota, 1 plus iota, multiply it again and again. Another method is what? Just use the properties of argument. So 10 times of argument of 1 plus iota is what you're going to get. Okay, plus 2k pi, so that the value can be written in the principal domain. Okay, so this is going to be 10 times of pi by 4 plus 2k pi. Okay, this is how much? This is nothing but 5 pi by 2 plus 2k pi. Now 5 pi by 2 is 5 pi by 2 is is what? 5 pi by 2 is 2.5 pi. That is 2 pi plus pi by 2. Yes or no? So over here, look, if you want to bring it between minus pi to pi, we need to take k as minus 1, because the moment we take k as minus 1, this value is going to be what? 5 pi by 2 minus 2 pi, that is equals to pi by 2. So this value will come in the principal argument, that is between minus pi to pi. Yes, minus pi to pi it will come the moment we take k is equal to minus 1. So this 2k pi is there so that ultimately you can bring that value in the principal argument. Otherwise there is no role of this, and I think the problem can be easily solved with the help of using these properties. So pi by 2 was the answer. I hope this thing is clear to all of you guys. Similarly, you can do this. This 3 will come outside, and if you talk about this, then pi by 3, the value of theta will be pi by 3. X is negative and y is positive, so pi minus pi by 3 will be the principal argument. So 3, this is there. Okay, just write 2k pi as well over here. Over here also 2k pi you need to write down. Now, if the principal argument is asked, then this is nothing but 2 pi plus 2k pi. That means we need to take k is equals to minus 1. So this value will be 0, and this belongs to minus pi to pi. So the answer over here is going to be 0. Okay, if the principal argument is asked. Right? Okay, if z is a complex number such that mod z is equals to 4 and argument of this is this, then z is equals to what? Okay, let me tell you this. Mod z is equals to 4 and argument of the complex number is 5 pi by 6. Then there are multiple ways. Z can be written as mod z into cos theta plus I sin theta, where theta is nothing but argument. Theta is argument. So one way is this. Another way is z is equals to mod z into e ki power I theta. This is Euler form. And this is polar form. So you can just remember this and the question is done. Right? Okay. So z can be written as mod z, that means 4 into cos 5 pi by 6 plus I sin 5 pi by 6. Now I hope that you know a bit of trigonometry. So cos 5 pi by 6 is going to be minus cos pi by 6, that is minus root 3 by 2, and this is going to be half. So this can further be simplified and the question is done. Yep. Okay. Talking about this, z minus 25 iotas modulus is less than or equal to 15. Now understand the distance between z and 25 iota is less than or equal to 15 is what the expression given to you. You said fine, okay. Can you plot 25 iota? 25 iota is going to be somewhere over here. The distance between z and this 25 iota is less than or equal to 15 means z can lie anywhere on this circle. Z can lie anywhere in this region, on the circle or inside the circle, because less than or equal to is given. If equal to is given, then only the circle, not the inside part. And if only less than is given, then not the boundary, but the inside portion only. Since both are written less than or equal to, that means the entire region z can lie. Okay, the radius is 15 because the distance is ultimately less than or equal to 15. So this point is going to be what? 0, 10 I, or we can say 10 I. Yes or no? Okay. Now maximum argument of z minus minimum argument of z ka modulus is what the question asking us. Now this problem is of circles, not of complex numbers. But as I told you, if you have a good command over geometry, then it is going to help you in other topics as well. So this is 25 iota. So this point is same as 0, 25. This radius being 15. So this is going to be 0, 10. Okay. Then the minimum argument. Now let me tell you this very important concept. The minimum argument is going to be of this complex number, and the maximum argument is going to be for this complex number. Yes or no? So this is the minimum argument of z, and over here it is going to be the maximum argument of the complex number z. because z is lying anywhere on this. So all the complex numbers will be having different arguments, because z is anywhere on this red in this pink circle, right? So this is going to be the minimum argument, this is going to be the maximum argument, tangents. Okay, now if it is asking us about the maximum argument of z minus minimum argument of z, means the question is asking us about this angle. So you can imagine a circle is there having center 0, 25 and radius being 15, and two tangents are drawn from 0, 0, and ultimately what we want is the angle between the two tangents. Yes or no? Okay, the radius is given to us 15. Okay, and this distance between the point from which tangents are drawn and this is 25 given to me. Okay, can we first find out this particular angle, kids? Yes, it is going to be what? It is going to be 625 minus 225. If we do, this is 20. Yes, okay. If this is 20, then if this is theta, so theta, cos theta is going to be 20 over 25, that is equals to 4 by 5. That is theta equals to cos inverse 4 by 5. And then 2 theta, because the angle is going to be double. This angle and this angle are going to be identical. So 2 theta is going to be 2 cos inverse 4 by 5. So 2 cos inverse 4 by 5 is going to be the correct answer. Right? Yep. Look, this is the problem of circles, but asked you in the form of complex numbers. That's why I am telling you to have good command over the geometry of complex numbers, because that geometry is going to help you in coordinate geometry as well. And if you are having good command over coordinate geometry, then complex numbers is also going to be easier for you people. So I hope you are getting my point, and what am I trying to convey from here, that these things are very important. So have a good clarity over these particular areas in case you haven't done it correctly yet. Okay, let z and w be the complex numbers such that this equation is there and also this relation is being followed. So over here you can use the property of argument, that argument of z plus argument of omega or w is equals to pi. This is not omega, this is w. Don't consider it as cube root of unity. A lot of guys does that. Okay, yes, this is z plus iota omega bar, z bar plus iota omega bar is equals to 0. Now taking conjugate, I hope you know how to take the conjugate. Conjugate can be split whether plus is there, minus is there, multiply is there, divide is there, not an issue. So this is z plus iota bar and then omega will come. Iota's conjugate is nothing but minus iota. So z minus omega, this kind of a thing is what you're gonna get. So z will be equal to iota omega. Okay, then the w can be written as z by iota, right? Okay, so w can be written as z by iota. So putting it over here, argument of z plus argument of z by iota is equals to pi. Then over here, if you apply the property of argument, that is of logarithms, then this can further be written as argument of z minus argument of iota is equal to pi. So this is 2 argument of z coming equal to pi plus pi by 2, because argument of iota is pi by 2. I hope you know this. So argument of z from here can be rewritten as 3 pi by 4. Yes or no? So the answer is going to be C for Calcutta. So whenever these kind of questions are favorites of IIT JEE, they have asked multiple problems based on this. So always remember this kind of a method you need to apply in order to solve the problem. This is a very important method which you must always keep in your mind, how to proceed in such kind of problems. Okay. Yep. Moving on to the next thing, polar form. Polar form is quite same and the one that you might have done in trigonometry as well. If this is the point x comma y, then this distance is going to be x square plus y square. This will be forming some angle with the positive x-axis. If that is the case, then this length is going to be x cos theta. This length is going to be x y sin theta. So x, if this is the case, then the things are done, right? Okay. No. These are some, okay. Let me call it as R. If I'm calling it as r, then this is r cos theta and over here is r sin theta, right? So x comma y can also be rewritten now as r cos theta comma r sin theta, where r is nothing but modulus, or x comma y can be rewritten as under root x square plus y square into cos theta comma under root x square plus y square into sin theta. So this is nothing but mod z cos theta comma mod z sin theta. That's it. Now you got nothing but the polar form, right? Okay, so polar form is quite easy, right? You must remember this as well, that cos theta plus I sin theta can be written as e to the power I theta, where theta is nothing but the principal argument. Okay, if e to the power I theta you want to write down, you can write it as cos theta plus I sin theta. But if you want to write down e to the power minus I theta, then over here you need to replace over here also minus theta. But cos of minus theta is cos theta only. And over here also you need to replace here and here, both you need to replace theta by minus theta. So sine of minus theta is minus sin theta. That's why this expression is coming out to be like this. Okay. Yep, do remember this. And the magnitude of e to the power I theta is nothing but equal to 1 only. That you guys can easily verify. Yep. Okay. We need to use Euler form whenever big and bad powers are there. Use Euler form whenever big and bad powers are there. Big and bad powers are there. Okay. Whenever big and bad powers are there, use this form. Okay. Euler form of iota, you must remember this, as it is a very, very, very important and very basic term. So the modulus is 1 and e to the power I pi by 2. The argument, the Euler form of 2, the modulus ka value is 2 and e to the power I is 0. Okay. If we talk about this, then argument ka process, you guys know, it is going to be e to the power I pi by 3. Yes. So modulus you guys know, argument also you guys know, and you just have to use that because Euler form is nothing but modulus value times e to the power I argument. This is nothing but your polar bit. This is nothing but your Euler form, right? Okay, so this is what we have done. I hope you guys are clear with this particular thing. Okay, talking about this now, look. Method 1 of solving the problem is like this, that we know the value of cos pi by 3, sir, it is half. We know the value of sin pi by 3, sir, it is root 3 by 2. We know the value of cos pi by 6, sir, root 3 by 2, and then this is 1 by 2. Then what we can do is we can rationalize this. And then we can solve. But lengthy. Okay. Everybody can solve by this method, but this is going to be a bit lengthy. So we need to apply we need to apply something else over here. So the numerator can be written as e to the power I pi by 3, yes or no? The denominator we have just seen, can it be written as e to the power I minus pi by 6 or not? The same expression can be rewritten like this. If yes, this can be further rewritten as pi by 3 plus pi by 6. Pi by 3 plus pi by 6 is nothing but pi by 2, by the way. And e to the power I pi by 2 is nothing but iota. We have just seen on the previous pages, if you can recall. Yes. So look, with the help of Euler form, this problem has been so easy. But if you move in a conventional method, then definitely it is going to take a lot of time, right? So try proceeding through Euler form, because Euler form is going to be a bit helpful in these kind of scenarios. De-Moivre's theorem, if we talk about, then cos theta plus I sin theta to the whole power n can be rewritten like this. Now it's a very easy thing. This can be rewritten as e to the power I theta to the whole power n. Now n can be multiplied with I theta, so it will become something like this, and this can be further rewritten like this. Yes, so if n is any integer, you can do this. There has to be no issue at all. Let's say I want to evaluate this particular thing. Let's say I want to evaluate this particular thing. Now this can be easily done with the help of De-Moivre's theorem. This is e to the power I pi by 4 to the whole power 8. If that is there, then e to the power I pi by 4 to the whole power 8 is there. Then this can be written as e to the power I 8 pi by 4. 8 pi by 4 is nothing but 2 pi. So e to the power I 2 pi, it will become, now that is nothing but cos 2 pi plus I sin 2 pi. Remember, cos theta plus I sin theta is equals to e to the power I theta. So cos 2 pi is 1, sin 2 pi is 0. So this thing is nothing but equal to 1, right? Yep. Okay. Application of De-Moivre's theorem over here. Now look, if this kind of a thing is given to us, then one way is what? Multiplying it 3 times. Another way is what? First writing down the modulus. Modulus's value is 2. Okay. Then writing down the argument. Argument is pi by 3. So we are done with the basic base thing and then whole power 3. We need to simplify this. Okay. Can we write it as 2 to the power 3 into? Can we write it as 2 to the power 3 into e to the power I 3 pi by 3? Now 3 pi by 3 means 3 and 3 gone away. So this is going to be e to the power I pi. Okay, so this is going to be 8 times of cos pi plus I sin pi. By the way, sin pi is nothing but 0 and cos pi is nothing but minus 1. So the answer is going to be minus 8. That's it. The problem is done. Have a look at this, everyone. Yep. So look how easy the problems becomes if you use the Euler form and De-Moivre's theorem. Okay. Yes. Let's say this kind of a problem is asked, root 3 plus iota ki whole power n plus root 3 minus iota ki whole power n is equal to this. Prove that. Now look, root 3 plus iota, can it be written like this? Or 2 times e to the power I pi by 6 ki whole power? Yes, we can write it like this. And similarly, this thing, if we talk about this root 3 minus iota can be rewritten also as something. It can be rewritten as e to the power 2 times of e to the power minus I pi by 6. Now, if you want to find out power n, then here also we need to do the power n. So it is going to be 2 to the power n into e ki power minus I n pi by 6. And there also, if you want to find out the power n, so over here also we will do power n and over here also we will do power n. So we will ultimately come back to this. Now adding both, you will get to your answer, right? I hope you understood this. There has to be no confusion at all, and the problem will be simplified because this and this are cancelled. I hope you remember sine of minus theta is equals to minus sine theta, and cos of minus theta is equal to cos theta only, not minus cos theta. That's it. De-Moivre's theorem for rational numbers and cube roots of unity. Okay, yes. Now let's understand for rational numbers. When integer was there, not an issue, but whenever an rational number is there, there can be a few things. Okay, now let's understand this. Cos theta plus I sin theta to the whole power p by q is written, where p by q is the rational number. So this kind of a thing you have to write down. 2k pi plus p theta upon q. 2k pi plus p theta upon q as the argument, where k is equal to m into p and k will go from 0 till q minus 1. 0, 1, 2, 3 till q minus 1. That means what? Let's say I am asking you this expression. Let's say I am asking you this expression, cos theta plus I sin theta to the whole power 1 by 3. Okay. Now what you will do is you will write it as equal to cos of 2k pi plus theta 1 into theta divided by 3 plus I sin 2k pi plus 1 into theta divided by 3. Can you compare this? Okay, number 1. Number 2, here k will go from 0 and then one lesser value than the denominator of the rational number. That is k equal to 1, 0, 1 and 2. Okay, these 3 values of k you will put, you will get 3 different values of this number. Basically is what I am trying to say. 3 values you will get because power 1 by 3 was there. Okay, if power 1 by 4 is there, then you will get 4 values. Okay, let's say this z cube is equals to 1, then this can be further rewritten like this. Over here, if you factorize it, you will get it like this. Then from here z is equals to 1, which is a real number, and then this equation. You must remember that the roots of these equations are z is equal to minus 1 plus minus under root 3 iota by 2. This is a very important thing. 1 is omega. We call this particular thing as omega. and we call this thing as omega square. We call this thing as omega square. So z cube equal to 1 does have 3 roots. 3 roots. What are those 3 roots? One is 1, another one is omega, another one is omega square. Omega is nothing but minus 1 plus root 3 iota by 2. And omega square is nothing but minus 1 minus iota root 3 by 2. Okay, must remember this. Okay, we can do this through the De-Moivre's theorem as well, because z cube equal to 1 was there. So we can write down z as 1 to the power 1 by 3 as well. Now 1 can be rewritten as 1 into e to the power I pi by 2. No. It can be rewritten as e to the power I pi. Yes or no? Or 0. E to the power I is 0. To the whole power 1 by 3. Now, whenever rational power is there, you will do what? 2k pi plus p theta upon q. You will do. Remember? Right? And k's value will be 0, 1, 2 and 0, 1 and 2. So there if you go, you will get these kind of values, and these kind of values you will put k equal to 0, 1 and 2. You will get same values only, that is 1 omega and omega square only. So that is another way of finding out cube roots of unity. So these are the values we have got by putting the values of k as 0, 1 and 2. Right? This should be clear. Okay, you need to remember a few properties of cube roots of unity. Omega ka cube is always equals to 1. The sum of 3 consecutive powers of omega is always equals to 0. Okay, then omega ka square ka whole square, if you do, it is going to be omega to the power 4, which can be written as omega cube into omega. So that can be written as 1 into omega, that is again omega. Omega square, if you take omega square, if you multiply by omega and omega, it is going to be omega cube by omega. Omega cube is nothing but 1. So this is nothing but 1 by omega. Omega is equal to omega bar ka omega squares bar, because I hope you know that omega is nothing but minus 1 plus iota root 3 by 2, and its conjugate is nothing but omega square. So that you can easily see. You must remember that this equation do have 2 roots. One is omega and one is omega square. Okay. Yep. Omega and omega square are the roots of this particular equation. Z square plus z plus 1 can be further factorized like this. Z minus omega into z minus omega square. Then minus omega and minus omega square are the roots of this equation. This is also a very important result. This thing can be further factorized into z plus omega into z plus omega square. Then these things can be rewritten as well. There has to be no confusion at all. Okay. The modulus ka value of omega is equal to 1, and the value of modulus of omega square is also equals to 1. The argument of omega is 2 pi by 3, and the argument of omega square is minus 4 pi by 3. Minus 2 pi by 3. Principal argument, or 4 pi by 3 as well if another argument is asked. 1 omega and omega square, they always form a geometric progression. Yes, geometric progression means middle wale ka square is equals to sum of the rest 2. That is happening over here. Okay, 1 omega and omega square, they form an equilateral triangle with centroid at origin and the length of the side being root 3. Okay, let me tell you this. This is 1, 0. This is minus 1 by 2, comma root 3 by 2. This is minus 1 by 2, comma minus root 3 by 2. You can evaluate the side length. The side length is going to be root 3 only, right? The centroid of this equilateral triangle is this 0, 0. And by the way, for an equilateral triangle, if you remember, for an equilateral triangle, centroid, circumcenter, orthocenter, and incenter are all same. Are all same. Yes or no? Yep. Okay. So keep this thing in mind always. And 1 omega square are concyclic points lying on a unit circle centered at origin. Okay. Concyclic points means lying on a same circle. Okay. Yes. Alright, problems on properties of cube roots of unity. Let's say if alpha and beta are the cube roots of unity, then show that alpha to the power 4 plus beta to the power 4 equal to alpha beta. So we can take alpha as omega and beta as omega square. Put these values over here and you will be able to find out the result. I don't think there has to be any confusion because a basic property is 1 plus omega square is equal to 0 only. Sum of nth roots of unity. So on the same pattern, 1 plus omega square was there. So here nth roots are there. So n roots are there, out of which one has to be 1 and the last one has to be n minus 1th, alpha n minus 1th. Summation has to be equal to 0. Yep. Okay. And this is also one important result which you should remember, right? Like over here, if 1 to the power 1 by 3, we want to do 3 roots will be there, 1 omega square. If 1 to the power 1 by 4 is there, 4 roots will be there, 1 iota square and iota cube. Now, let me tell you this. If 3 roots are there, then the entire circle will be divided into 3 equal parts from the x-axis. So if 2 pi angle is there and we want to divide it into 3 equal parts, so 1 will always be 0. So, okay. So it has to be divided into 2 pi by 3 things. Okay. This will also be 2 pi by 3. This will also be 2 pi by 3. And that's why 3 roots were coming. 1 omega and omega square. If I'm looking for 4 roots of unity, then this entire circle will be divided into 4 parts. Now 2 pi by 4, if you do, it will be pi by 2. Look. So this is 0 degree. And over here pi by 2. Then over here pi, and over here minus pi by 2 or 3 pi by 2, anything you can say. So over here 4 roots are there. 1 iota, minus iota, and minus 1 and minus iota. Right? So look, that's why these 4 roots were coming. 1 iota, minus 1 and minus iota. Right? So over here n roots are there. Circle will be divided into n equal parts. Okay? Over here pi by 2, pi by 2, pi by 2. Right? I hope you understood this thing. There has to be no confusion at all. Right? Okay. Now these are few properties which you should keep in mind. All nth roots of unity lie on a circle with unit radius. That means having radius 1 and centered at 0, 0 and radius 1. Right? Okay. And this is the polygon. I hope you can easily have this. Okay. Represent 4th roots of unity on argand plane. So iota, 1 and minus 1. 4 roots will be there. Basically not an issue because the circle will be divided into 4 equal parts. Let Z1 and Z2 be the nth roots of unity which subtend a right angle at the origin. Now understand. Right angle at the origin means 90-degree angle should be there between those 2 roots. Right? Then n must be of the form what? We have just seen that if it is a 4th root of unity, then the angle will be 90 degree. So 4k. Yes or no? Because if 8 power, if you do 1 by 8 power, then you will divide the circle into 8 equal parts. In that case also 8 roots will come, and if you pick the first one and the third one, the angle between them will be 90 degree. Right? Yes. So you can solve it in multiple ways. I have just told you an objective method. So with the help of that also you can solve it comfortably. Right? Okay. We need to solve this particular equation. Now I would like to tell you one thing. In case you don't know that result, you must know, as it is very important. Z minus 1 times Z minus this, Z ki power this, Z ki power this, and so on till 1. This is equal to Z to the power n minus 1. So over here you can see that this thing on the left hand side can also be rewritten like this. Right? So from here you can say that Z to the power 6 minus 1 should be equal to 0. So from here you can say that Z to the power 6 equal to 1. From there you can say Z is equals to 1 to the power 1 by 6. So 1 can be rewritten as e to the power I0 ki whole power 1 by 6. And since this is the rational number, so this thing can be further rewritten as 2k pi plus 1 into 0 divided by 6 plus I sine 2k pi plus 1 into 0 divided by 6. If this is the case, here k will go from 0, 1, 2, 3, 4 and 5, right? These values of k you will put and you will get different values of z, and you will get all of your roots, and your roots will be coming out to be like this as I have shown. Right? More problems on nth roots of unity you guys can see over here is if x plus 1 by x equals to 2 cos theta, then x to the power n plus 1 by x to the power n is going to be what? So these things can also be solved quite easily, because if you take x equals to 1, then theta equals to 0 degree will come objectively if you want to solve this equation, because if x plus 1 by x equals to 2 is there, then x and 1 by x should both be equal. You might have studied this in AMGM. Okay, so from there x will come out to be 1. So if x equals to 1, then which of the following thing? This will never be your answer because this will give you 0 as the answer. This will not be your answer. This will give you 2 as the answer. So the answer has to be B for Bombay. Look, objective tricks. With the help of objective tricks, you guys can solve your question in just a matter of few seconds. Wait a minute. 1 plus 1, 2 will come. Sorry. 1 plus 1, 2 will come. So this option will give you 1 only. So that's why this is not your answer. The answer has to be this. Right, because x equal to 1 if you put over here, then cos theta will be equal to what? 1. That means theta has to be 0 degree. So theta 0 degree. If you put which of the following option give you 1 to the power n plus 1 by 1 to the power n, that is equals to 1 plus 1, that is equals to 2. Which of the following option is giving you 2 when you are putting theta equals to 0 degree? Has to be your answer. So one way is this. Another way I have attached for you guys. Refer it for the subjective method. Right? Okay. Equation of a straight line, if you see, the equation of the straight line in complex numbers can be rewritten as a bar z plus a z bar plus b. Okay, here a is a complex number. Here a is a complex number. That's why a bar is also coming. But b is a real number. Do remember this. So, which of the following are representing a straight line? Look, a bar z plus a z bar plus 3. Yes, this is the straight line. If this is a bar, then your a is going to be what? If this is your a bar, then your a is going to be 2 minus I. Okay, so this is not a straight line. Not a straight line because this is not following, the equation is not following a bar z plus a z bar plus b equals to kind of a thing. Yes? Okay. Now, if a is equals to 2 plus 0i, then a bar and a are going to be same only. So this is going to be representing a straight line. And over here also, if you see, this is going to represent a straight line because a bar's value is nothing but iota over here, right? Yes. Moving on to the next thing. Equation of a straight line in other forms. If I would like to ask you, then section formula, you guys know z1, z and z2. Z is dividing the line segment joining z1 and z2 in the ratio lambda is to 1 minus lambda. So you can use this form. Not an issue. Slope method also you guys can apply. Z2 minus z upon z minus z1 will be equal to, this is a straight line. So you guys can say that z minus z1 upon z2 minus z1 is equal to its conjugate. Yes or no? That's it. Because you can prove it from here. You can take the lambda wale terms together and you can write down the value of lambda as z minus m this, and where lambda is real, if lambda is real, then the conjugate of this has to be equal to itself only, and that is what we have applied, right? Yes. Okay. Equation of circle. I told you that distance between z and z0 will be represented by mod of z minus z0 equal to r is written. So r is a constant always. So circle will be having z0 as the center and the radius will be equal to r. If center is at origin, then mod of z0 has to be equal to r, right? That we have already seen. So if you want to simplify this equation, then you can square both sides. Now I hope you know that mod z square is nothing but z into z bar. So the square of modulus of anything can be written as z minus z0 into its conjugate. And then if you simplify, this equation is nothing but of your circle z into z bar minus z into z0 bar minus z0 into z bar plus z0 z0 bar minus r square is equals to 0. Okay, and you can write down the center as minus a and radius of this circle as under root a square minus b. Okay, problems on equation of circle, if you do, find center, and I have just told you minus a is the center and under root of mod a square minus b is nothing but the radius. Now you just need to find out the a. So z bar plus a bar z. A bar z is there. So a bar is nothing but 3 plus 4i. So a is going to be nothing but 3 minus 4i. So minus a is going to be your center, means minus 3 comma 4 is your center. And the radius is what? Radius is this. So if you do the modulus, modulus is 5. 5 minus 5. Is it a point circle? No. Mod of a square minus b. So mod of a square is going to be how much? Yes, 25. Sorry. 25 minus 5. Absolutely. B's value is 5. The real number. Right? I don't think there has to be any issue. Remember, center is nothing but minus a and the radius is nothing but under root of a square minus a, under root mod of a square minus b. Okay, this value is nothing but B. Whatever is written along with the Z bar has to be your A. Whatever is written with Z has to be your A bar, and Z into Z bar has to be there, right? That's it. Okay, center of the circle represented by this. I think you can solve it quite comfortably. There has to be no issue at all. You can do like this. You can put Z is equals to X plus IY. One method is that. If you do it by that method, you will be having equation in terms of X and Y. So from there also you can find out center and radius. So I'm giving you this part as homework. I think you can definitely do this homework. There has to be no issue in order to solve this particular thing. Okay, do tell me the answer in comment section below the video. Comment section below the video. Okay. Yep. So I have attached the solution for you guys. So that's it for the day. That's it for the day. You have to practice previous year questions of both JEE mains and advanced on your own. And we will be covering that in the upcoming lectures as well. But as of now, I think the entire theoretical portion that I have covered in this session will be self-sufficient for you guys. And you will be able to, score good in this topic. If you haven't learned it yet, go through it now once again, because at first when you learn this topic may seem a bit different or a bit difficult, but the more you practice it, it is going to be easy and smooth. And again, I told you what, if you want to master coordinate geometry and complex numbers both, that will be a great thing, because the geometry is same, only the way of writing down the things is different. So marks, questions coming from this portion can be of coordinate geometry. So if you know coordinate geometry well, you can master complex numbers as well. And if you know complex numbers well, you can master coordinate geometry as well. So that's why geometrical portion is very, very, very important. We will keep the session till here only. We'll meet you with another session in the upcoming days. Keep learning, keep shining, keep rocking, keep enjoying. Let's make most out of this and let's nail the upcoming JEE examination. See you in the next session. Bye bye. Take care. Happy learning.